Hello and welcome to another video with Mr. Peters. Today we're going to be looking at some revision on time. So I'm just going to share my screen with you now and let's have a look at what we've got for today. So time revision with Mr. Peters. So what we've looked at during this unit, well, we've looked at reading an analog clock briefly. We've looked at reading 12 and 24-hour time, which means we have learnt to read a digital clock. We have learnt to read and construct timelines and making sure we have appropriate scales on our timeline. And we've looked at reading and constructing timetables and calculating with time, so word problems. So we're going to look at some of this today. So let's go over a few of these things together. So units of time. We always start with the smallest unit and work our way up. So we've got seconds. That brings us to minute, which is equivalent to 60 seconds. That brings us to an hour, which is equivalent of 60 minutes, which brings us to a day, which is 24 hours, a week, which is 7 days, a month. Now, months are a little bit tricky, depending on the month that we're working with. So it's either 28, 29, 30, or 31 days. And I'll give you a breakdown of the months in a moment. And that brings us to the biggest unit of time that we're going to normally use, which is a year, which can be 12 months or 365 days. So months of the year. If you want to pause the video now would be a good time so you can look more specifically at the table here on the left. That is a breakdown of how many days are in each month. Now you'll notice February has 2 dates. My question is for you, why does it have 2 dates? Ask someone around you or you can research it, why there are 2 dates on February. So a quick note, as the number of days in a month varies, this also means that the number of weeks in a month vary too. People often use approximations when calculating the number of days in months. For example, it is common to use the assumption that a month contains 4 weeks, even though only February in a common year actually does so. And a top tip, if you're converting between months and weeks, the best way to do so is via years because they always contain 12 months, even in a leap year. Hint back to February. To convert months to weeks, divide by 12 and multiply by 52. To convert weeks to months, divide by 52 and multiply by 12. The answer you get will be a good approximation. Writing in time. So you're looking at my diagram here on the left. I've got 4 different times. Each example, I've given you a demonstration of time in words. So this example here, it says 2 o'clock. That's written in words. Down the bottom here, pointing to the analog clock, we've got the small hand. Now, reminder, the small hand is the hour hand. So there's always the small one that indicates the hour, and the longer hand on the clock, an analog clock, indicates the minute. So this clock here is demonstrating 11:30, or you could also say 11:30. And my final demonstration here, we have 12 and 24-hour time. Now, 12-hour time is written up the top as 7:45 p.m. in the green, and below in red as 19:45, which is our 24-hour time. Now, we do expect you to know how to read an analog clock, how to read 12 and 24-hour time, and how to write time in words. But let's break that down a little bit further. Let's move me over here. So there are different ways to write time as I've just gone through. Let's break it down a little bit further. When using the 24-hour clock, the 24-hour cycle starts with the time 0000, which is midnight, and runs all the way through to 23:59 before rolling over to 00 again to indicate a new day has begun. When using the 12-hour clock, the 24-hour period is divided into 2 12-hour periods. Both midnight and midday are 12 o'clock. Time before midday, so noon, is designated AM, and time after noon is referred to as PM. So noon itself is PM, which will then lead to 1 PM and so on to midnight, which will then be 12 AM. So for example, 4:10 PM is the same as 16:10. Note that we never write 16:10 PM. The use of the AM and PM is only for the 12-hour clock. The fact that this is 24-hour time and it's past 12 already tells me it's in the PM. So you don't need to write PM. It's already indicated by the time itself. And the last one, you can also describe time in words, such as 10 minutes past or after 12, or 10 past 12. And this works up to halfway through an hour. We describe the minutes past the hour, beyond half past. We talk about minutes to or before the next hour. A time on the hour, for example, 2 p.m. can be referred to as 2 p.m., 1400, or 2 o'clock. Okay, now calculating the passage of time. In the normal way of things, to calculate how much one thing is greater than another, you would simply subtract one from another. However, subtracting time is complicated because it's not decimal, so it's not out of 100. Instead of using columns being hundreds, tens, and units, which we're used to, they are hours, minutes, and seconds, as we looked at before. Let's look at some examples. So, Pat was due to catch a train at 11:44 a.m., which she has just missed. The next train is not until 1:17 p.m. How long will she have to wait? So this question, before I even start looking at anything, I need to look at the key facts within this question. So we've got the beginning time, we've got the next time, and then we've got what the question is asking us is how long is in between these two times. So I'll just move this down here. Before you start, the easiest thing to do, a bit of a hint from Mr. Peters, is to convert all the times to 24-hour time. So 11:44 a.m. becomes 11:44, and 1:17 p.m. becomes 13:17. Now, a hint for calculating from the PM time, so afternoon, to 24-hour time is to do whatever it says in PM. So 1:17, add 1200. So 1200 plus 1:17 gives you 13:17. Let's continue on. So number of minutes from 11:44, we're going to round up the next hour to 12 o'clock is 16 minutes. So we'll write that down, 16 minutes. The number of hours from 12 to 1 o'clock or 12 to 1300 is 1 hour. And the number of minutes from 1 o'clock at 1300 to 13:17 is 17 minutes. So now we've got 16 minutes, 1 hour, and 17 minutes. So we're going to bring all those together. So the total time that Pat will have to wait is 1 hour plus 16 and 17 minutes, giving us a total of 1 hour and 33 minutes. So hopefully you paused the video and you had a go at this question yourself. If not, have a go at this next one in a moment. Now this one's a bit of a lengthy question, so we're going to break it down into steps. Let's read the question first. So I am organizing a series of canoe races and have synchronized clocks for the start and the finish. The plan is for the first race to start at about 30 minutes after the synchronization. Then 4 more races to start at 2-minute intervals after that, but it never works exactly. The starter keeps a record of the exact times, and it turns out that on this occasion, the races started at 28 minutes and 2 seconds, 30 minutes, 32 minutes and 15 seconds, 34 minutes and 40 seconds, and 37 minutes. Okay, so by looking at this question, we can see that the question is right. The times haven't started at 2 minutes after each other. They're quite delayed. We also can see that there are 1, 2, 3, 4, 5 races that occurred on this race day. So let's see what the first part of the question is. So the finish line has a clock, which is exactly synchronized with the start clock, and the finisher records the times on the clock when the racer crosses the line. So what that means is once the racer has left the starting block, their timer has started until they cross the finish line, and that time is written down. So for each of the following times, work out how long the competitor took. Okay. So James was in the first race, so he started, looking back at the question, at 28:02. He crossed the finish line at 59:02. Okay, so we need to work out how long he took. So James started at 28:02 and finished at 59:02. How convenient. There are no additional seconds. It lines up exactly having 2 seconds. So the question becomes quite simple. You can simply subtract 28 from 59 and discover that he took 31 minutes exactly. So that's the first race. If you're working on paper and you had this written out, you could even cross that time out to know you've already used that time. So have a look at the next one. So same information again. Simon was in the fourth race. He crossed the finish line at 1 hour, 10 minutes and 34 seconds. Okay, so fourth race. Let's go back to our question. It's not the 28-minute one, not the 30-minute one, not the 32-minute one, but the 34-minute one in 40 seconds. So Simon started at 34 minutes and 40 seconds, and he finished at 1 hour, 10 minutes and 34 seconds. So as I said, Simon started at 34:40 and finished at 1 hour, 10 minutes and 34 seconds. So to simplify things, like I said earlier in this video, let's bring it all together. So let's call it, instead of an hour, 10 minutes, 34 seconds, let's take our hour, convert that to minutes. So 60, add our 10 to that. So it's 70 minutes and 34 seconds. So let's break it down a bit further. So from the 34 minutes and 40 second mark to the 35 minutes, it's 20 seconds. So from this time to this time, it took 20 seconds. From 35 minutes to the 70-minute mark is exactly 35 minutes. So from that 70-minute mark to the 70:34 is 34 seconds. So that time is from up here that we calculated earlier. The Simon took a total of 35 minutes plus 34 seconds plus 20 seconds, bringing out his total time to 35 minutes and 54 seconds. Okay, another one. Let's have a look. Mary was in the second race. Okay, let's stop there. Let's go back to our question. The second race. So Mary started at the 30-minute mark exactly. And she crossed the finish line at 1 hour, 15 minutes and 2 seconds. Okay. So Mary started at 30 minutes exactly and finished at 1 hour, 15:02. And let's convert that again. Take the hour, make it 60 minutes. 60 plus the 15 gives us 75. So 75:02. And again, this question now becomes quite straightforward because we're now working in the same value. So there are no seconds before the next minute, but there are 45 minutes from 30 minutes to 75 and 2 seconds from 75 to 75:02. So when we bring that together, she took 45 minutes and 2 seconds. So pause the video now if you need to reread that. I did go through that quite quickly, but otherwise I'm going to move on now. So calculating the total amount of time spent. So sometimes you might need to add up how much time you have spent on a task that you have completed over several days or sessions. Adding a list of hours and minutes isn't as straightforward as doing normal addition calculation because, as I said before, we're not working in the decimal system. Let's look at one example. You're doing a gardening job for a neighbor who has agreed to pay you an hourly rate of $10 per hour. On the first day, you spend 3 hours and 25 minutes on the task. On the second day, you spend 2 hours and 50 minutes. And on the third day, you finish it off in an hour and a quarter. You need to add together the three amounts. So 3 hours 25, 2 hours 50, and 1 hour 15. Now you'll notice right here at the end of this question, I've already done the calculation for us for today. I've taken the time, 3 hours 25, and I wrote it there. I took the next time, 2 hours 50, and I wrote it there. And the next one, even though it said hour and a quarter in words, I was able to convert that to 1 hour 15. So that way our three values all align. So the first step is to add together all the minutes. So I'm going to look at this. I've got 25, 50, and 15, which gives us a total of 90 minutes. And there's only 60 minutes in an hour. We should know that because we looked at that right at the beginning of this video. So the next step is to convert 90 minutes into hours and minutes, which we should know is 90 divided by 60 because there's 60 minutes in an hour. That gives us 1.5 hours or an hour and a half. The answer is a decimal, so we can convert it back to hours and minutes. So we convert 0.5, that's from our last answer, into minutes, telling us it was 1 hour and 30 minutes. As you can see here. Okay, let's keep going. Next, we need to add together the whole hours we've spent. So looking back up here at the question, we spent 3 hours on the first day, 2 hours on the second day, and 1 hour on the third day. So 3 plus 2 plus 1 is 6 hours. So now we add the total hours and the total minutes together. So we have our 6 hours plus our hour and 30 minutes, which gives us 7 hours and 30 minutes. Or you could say he spent 7 hours 30 spent gardening, or in decimal form, you could write it as 7.5 hours. All those answers are correct. Now, the question was, how much did he get paid? So our hourly rate was $10 per hour, and he spent 7.5 hours working. So we're going to go 7.5 times our $10, which gives us 75. So therefore, he earned $75. So to wrap things up, The most important thing when calculating the time is to check whether the answer looks about right. So always make sure when you finish your calculations, think through the time your answer practically. Think if he started in the AM and he finished in the AM on the same day, the answer can't be more than 12 hours. If he started in the AM and finished in the PM on the same day, your answer can't be more than 24 hours. So you need to think about it practically. Think about a clock, relate it back to something you're familiar with. Maybe it's your school day or how long you spend training, whatever it might be. So that's the end of this video. I hope you've learned something today. And as always, enjoy working on your math questions. Any questions, make sure you check in with your teacher. Thanks, guys. Bye.